Hey guys, it's Vince. Today we have a real interesting video from a beginning content creator. He has a little over 2,000 subs, where his channel is driven mainly around him building a supercar in his garage, but he felt he wanted to share a CNC build series with his audience. What makes this video very unique is the fact that not only do we get to see incorrect practices when building the controller, but we also get to see the ramifications from that as he goes through the build. Let's get started and jump right in.
Well, after a few days off to do some projects around the house, I'm back to working on the CNC. And you'll notice here that I have my electrical cabinet back and I have mounted the components inside just to test fit, make sure everything fits and looks like I expected it to. You can see all the components mounted.
Well, right out of the gate, the content creator is showing us his electronics enclosure. And in all the years I've done this has to be the smallest electronics enclosure selected I've ever seen by anybody, let alone a content creator. On top of that, we see a lot of redundancy again from the past content creator's video from last week to this week, meaning they're obviously taking a lot of this information and using it themselves. And unfortunately, it's incorrect information. We see 4 power supplies. The guy last week, and I'll put the excerpt of the video in here, shows that he used 2 power supplies. Why would you use 4 power supplies if you just knew the amperage that each drive required? Use a single power supply because, again, we're going to drop our electromagnetic interference. I've stated it last week. I'll say it again. It's because they're purchasing these kits from overseas China. And the issue with that is they just put kits together. They are not going to look at what is best for your system. They are looking at what's easiest for them to ship and what's easiest for them to package. It's that simple, guys. And unfortunately, end users like this, they think they're doing themselves a favor. They shoot themselves in the foot. Not to mention we have a VFD mounted literally maybe 2.5, 3 inches direct from the 4 drives he has mounted in the enclosure. We also have a USB breakout board, and we also have, 10 GX16s mounted in the top left corner of the enclosure. Now, I want you to think like this in your mind. When you're laying out your enclosure, picture 35 to 40% of the space used by wiring. We don't know if this has all his accessories in this enclosure right now. We see a fan mounted on the bottom, which is essentially being suffocated because I guarantee you that fan is not putting out that high a CFM, which stands for cubic feet a minute, which really dictates how much volume of air we're pushing over our electronics. But we can plainly see that this system is a direct recipe for disaster when it comes to stability. And you guys now are going to get to see, as we go through this video, what comes up.
In here, there's 4 power supplies, 4 motor controllers. This is the spindle motor control, breakout board, connectors, and the AC power input.
All right, so I've said this in previous videos, terminology is everything, and understanding why we use correct terminology. Mainly, it's because when you request support, if you're a novice like this content creator, you want to make sure that you're using the same terminology that's standardized in the industry so that the vendor understands exactly what you're referring to. So once again, it's motor driver and VFD, variable frequency drive, which is the controller of the spindle, okay? A lot of guys say, Vin, you're being nitpicky. No, I'm not being nitpicky. I get 40 to 60 emails a day, and a lot of times guys don't understand the correct terminology to use, and I know I'm not alone. So regardless if you buy from me, you buy from anyone, using correct terminology will assure, hopefully, you get the correct support.
There are some filters here on the top of the box, fan here on the bottom to pull air through and out. And these filters on top are magnetic. You can remove them and clean them, and they just stick on with the magnets.
So we've already gone over how his electronics enclosure is far too small for the application he's using as far as installing his automation components. Let's go into this in more detail. We've got a VFD, a variable frequency drive, which once again powers the spindle motor. Once again, drawing the most amount of amps. That means there's a large amount of electricity. That means there's a large amount of electromagnetic interference, which once again is directly beside all of his electronics components. That does not make any sense. That is not best practice. And that is the #1 rule of do not install your VFD inside of your electronics enclosure, and especially when we're using a metal electronics enclosure, as we all should be, because a Faraday cage works in reverse. What do I mean by that? Well, if metal is going to stop penetration of energy going in if it's surrounding your components on the exterior. On the interior, if we trap that electromagnetic interference, it's basically staying condensed around your electronics. Think about what I'm saying. Those principles work in reverse, guys. Now I want you to think of this. VFDs, and I'm talking all the units overseas, domestic, it really doesn't matter, but I'm going to give you a point of reference because I know details are everything, and I want you guys to understand how critical it is to understand what we're working with, including this content creator. Had he done the research, he would have realized, and when I say research, he would have just had to read the user's manual of the VFD, he would have realized that 40 degrees Celsius is usually going to be the optimum temperature in terms of maximum that you will achieve stability when using a VFD. Now, how do I know that? HY, Wan Yang, has actually put it in their user's manual, along with many others that come from overseas. It's pretty much the standard. Just to give you guys a breakdown, 40 degrees Celsius in the States in Fahrenheit is about 104 degrees Fahrenheit. That's really just warm for most electronics. They're saying that's the threshold of where this unit should be operating. Think about that. Think about what we've seen with that little computer fan that he mounted in the electronics enclosure, and think about how much CFM that's putting out and how it's being suffocated by all the components surrounding it. You have virtually no cooling. We have a large amount of amps being pulled, not just from the VFD, but when we combine all of the electronics components together, that's going to produce a byproduct of heat. We have problems, guys. And I'm telling you right now, that will exacerbate, especially when we factor in ambient temperature of where he's going to put this controller. We can already see the CNC router is going in the back inside of a garage. So we know it's going to be outside. That means it's going to be exposed to the elements, right? Right. The heat's going to go up. What do you think is going to happen or potentially happen? You got to ask yourself this. The next issue we have with a component installed within this electronics enclosure. We're using a USB breakout board, and many of you know that's a direct no-no. And why is that? Because Universal Serial Bus has no place in production CNC robotics when an end user / content creator or anyone expects their production robot to be stable. Now, I'm not saying for a hobbyist, I'm not saying for a machinist, I'm not saying for a Haas end user. I'm stating in general. There's no such thing as a hobby CNC. Every hobbyist expects a circle to be a circle and a square to be a square. Stop the bullshit. Stop arguing with me about hobby and this and that. The day that I can sell a CNC controller where an end user does not expect it to be accurate, I would be wealthy in 12 seconds. Think about it. Everybody wouldn't be complaining about their system not being accurate as far as what measurements, just cutting out components. So we already know that's BS. But when we think of USB, and I'm going to put it on screen right here again because I don't just speak words, I give you factual evidence. This is a direct email from Balzis, lead engineer over at CNC Drive, who manufactures the UC100 USB motion controller. Him and I were discussing the inherent instability of this controller, as many of people have been discussing, boards disconnecting, issues with random problems where they trigger an e-stop during cuts, and it would happen. 1 month it might be set, and the next month all of a sudden every time you touch the machine there's a problem. So there is no continuity on when you'll be bit by this animal, but rest assured it's still in the machine. You're not getting out of your machine if you think that there's some magic, oh, I figured it out, everything is stable. If you're using USB, there is not a 100% guarantee of stability, okay? No machine comes with that 100% guarantee. What we can do is mitigate as many variables as possible. After reading this email, if you still purchase a USB motion controller, then again, you have to question the intelligence you're throwing money at. Because I have seen many times guys say, well, I can't afford Ethernet. I really don't want to save anymore. I'm waited so long. I have great ideas, but I can't do anything. Guys, do yourself a favor. You would be better just pissing the money away, because taking a chance like this and spending 20 or 30 bucks on these breakout boards, you're essentially doing the same thing. And what's really sad is that you may encounter this with a very expensive substrate. Any substrate for that matter is going to cost something, and it can potentially destroy it. So again, proceed with extreme caution. So now we've seen not only an enclosure that is far too small for the components he has mounted within it. We also then have direct, confirmed, validatable evidence that the components he has installed are actually making the system inherently unstable or the potential thereof. We have to produce a system, if we're a content creator, that is done correctly so that our audience, his or mine or anyone's, is going to get the correct information. Because once again, correct information means success all the way around. Once again, if he doesn't hold himself responsible for the correct information, where do we go with this? How does this continue? If he's just basically spreading more and more misinformation just to get paid by AdSense, isn't that just as fraudulent as saying, hey, buy this internet ebook, it's going to make you wealthy, and it just takes your money? We hear about it all the time. Think about what I just said.
I have connectors here on the back side of the cabinet. I miscalculated on my connectors, and I think I need to add at least one more, maybe two more, but I have room here. I think I'm going to put one here and maybe one below the AC. I had forgotten about the power to the limit switches and home switches. I had sensor inputs coming back to the cabinet, but I forgot to run power out, and I also need one more connector for e-stop. So I think I need to drill two more holes here and mount connectors here also. And this is the front of the cabinet, which will bolt to the other half here, and you can see the connections here. This is USB to the laptop. This is the connection port for the MPG handset, and I'll have an emergency stop here and an emergency stop on the end of the table where I'll have my laptop. And I'll most likely wire those in series, so if you hit either e-stop, it'll shut down everything. And it's just the back side of this cabinet. Just back of the e-stop, and then some wiring just to jump over to the main part of the cabinet here. Once I finish the limit switches and homing switches, I'll come back and start wiring this. I'll probably remove some of these components, if not all of them, so I can get wires in here easy.
Now he's going to add even more ports to this already micronized electronics enclosure for these components, making it virtually impossible to utilize the proper double shielded cable, and of course using a ground bus, which we don't see a ground bus installed here. Again, it is best practice that all IDS systems utilizes the proper ground bus. Now when I say that, I get asked all kinds of questions. Vin, how do I ground my system? Every system is going to require a different process because all components are not the same. All components, meaning electronics enclosures, may have coatings. Those coatings need to be removed, and I've said this in previous videos, in order to have proper grounding. So if you really are serious about grounding your system properly and do not understand the process, I highly recommend you get with me and we'll set up a consultation to cover this. Will you have to pay for this consultation? Yes. Why? Because my information is going to save you money on potentially an unstable system. If you can't justify that, then naturally don't contact me. But if you want to do it right, that's the right way to do it. Now, as far as him talking about removing components in order to wire the system, how logical is that, guys? Think about that for a minute. He went through all of the process of measuring and mounting components, not one, all of them, before recognizing, hey, if I'm going to wire this, I'm going to have to remove them. Why is that? Because this electronics enclosure is not large enough to accompany doing the wiring process properly. We don't even talk about, once again, utilizing the proper ferrites for EMI mitigation or double shielded cable, because many of you already realize when you start working with double shielded cable, while it's flexible, it still needs room. And there's no room in that enclosure. It's so much so that he's willing to remove components and essentially double his workload, because most guys go and mount their components first, leaving enough space so that that process is done, and then they just wire the components to completion. You're seeing it and we're hearing it. Once again, videos really take the guesswork out of me trying to explain that point of logic.
Start wiring this up, this breakout board, and I have finally given up. I cannot get this to work. There's the instructions that came with it are very vague, and they have nothing covering the issues that I can't get to work in the instructions, and there is no technical support dealing with this company in China, because I basically bought the parts through a broker and not directly from the factory, so they don't give me anything but generic answers when I ask questions.
I told you guys this video is a little different. It's interesting that this content creator is explaining how he's not getting any support on a breakout board that he purchased from a Chinese vendor. Now, he's saying that he bought from a broker, and that's just a fancy term for a vendor. We don't know if that vendor in his case was third party or not, but I'm going to state this. If you guys buy something, do not sit on it, number one. And what I mean by that is, don't buy something, put it to the side, and then start working on your project 3 years later. I hear that a lot. That's not best practice, number one, to your pocketbook. And number two, in the event you have a problem, too much time has passed for any payment protection. The best thing to do is buy when you're ready to use the component, and therefore, if you do encounter problems with support, you have a leg to stand on with your payment processor to get your money back. This is fact. Once again, it's interesting, the content creator is telling in a format that he's not directing his audience, hey, don't make the same mistake I did. You're better off doing what I just explained. No, he'd rather just sit there and explain it openly as like, hey, oh, well, this is where I'm at. Guys, I'm telling you now, be very, very careful who you give your money to when you start investing in overseas CNC components. The fact of the matter is, most of the manufacturers that actually build these components, they are just the manufacturer. Very few of them are designed or set up for support. That's where a vendor comes in that hopefully understands the genre. Unfortunately, most manufacturers don't vet the vendors, and unfortunately then what you get is vendors selling components online who really don't understand what they're selling. And believe you me, it happens all the time. Most of my consultations are driven around that. So once again, buyer beware.
So I had a couple people recommend, even when I started this, that I trash the Chinese breakout board. Let me show you that. Climb under here. This is the breakout board, which communicates between the computer and everything else here. And I have decided to scrap this breakout board and buy an American-made one. There are a few on the internet that are very popular with people. And the one I chose, I'll show you when it comes in. It should be here in a couple of more days. It has full instructions on the internet, lots of support, videos, and feedback from user groups and things that I can use to help program it and get it working correctly. So I'm at a standstill right now. I had hoped to have this thing finished and working, but I spent so many days trying to get this figured out and doing what I need it to do. I can't get it to work with the spindle motor and start and stop it from Mach 3. And I can't even get the MPG handset here to communicate and function correctly, although it was part of the kit. And I have tried everything that I know how to do, reading and watching videos and trying different things, and I have just given up. I just can't make it work. So I should be able to do this with ease with this American board once it comes in. So we are just waiting on that to arrive. I believe it'll be here in either 2 or 3 more days. Then I can install that and wrap this up and hopefully get this machine running. I am off work all next week, so I should have plenty of time to finish this and wrap it up and get a video published for you guys to see. So hopefully when you watch this next video, the machine will be running by then, or at least very close. But that's an update, and I'll keep you guys posted once this new breakout board comes in. Okay guys, here's an update. It's been several days since I've actually videoed, but I was having trouble getting the spindle motor here to function from Mach 3 desktop, and I was struggling with this Chinese made breakout board that came with my kit for the stepper motors and drivers and stuff like that. And I could never get this board to work, and there was just no instructions, or very minimum instructions, and no technical support at all. So I finally gave up and bought a different breakout board. You can see here I bought this one. Anyone that's in the CNC world will recognize this. This is a very popular board that is sold by Builder CNC.
All right, so the content creator feels that he wants to replace his Chinese breakout board that's USB to an American-made one. Now, I don't know exactly where he's getting his information from. Most of the people that are involved in this genre or getting involved in this genre realize virtually all of the electronics are manufactured overseas. So I'm not sure why he would think that another USB breakout board would be, once again, manufactured on American soil. It doesn't make any sense. Guys, you have to educate yourselves using the correct information from validated sources. This content creator, like many before him, really makes no sense in that they obviously know how to use YouTube, but they don't use it to actually source validated information. How does that make any sense? I'll never understand that logic. But once again, he essentially did nothing if he swapped a USB breakout board with another USB breakout board, because essentially he still built in the same instability within his system. And honestly, I see a lot of potential clients do this. They will run and basically chase their tail because all they do is exactly like he just explained. They'll go on forums, they look for the cheapest possible solution, and they think that these people on these forums understand what they're doing. And my question is simple. If that was the case, why would they be on a forum? Once again, where is the logic? Most people go on forums because they're having issues themselves. If they're having issues themselves, that means they don't typically understand the hardware-software combination they're working with. Why would you be taking advice from these people who are not validated sources of actual information that can be used? It makes absolutely no sense. And yet you'll have guys do this, and then they're the same people typically that complain their system doesn't work. And then when I ask for money because I am a validated source, they'll say, no, I don't want to pay you. Okay, then you deal with it. There's a point of intelligence that comes when you purchase a robot of any type. And if you're buying a robot and you don't understand that robot, you cannot be ignorant. And when I say that, I mean it. This is not drywall. This is not you painting your house. This is not the general type contracting type stuff most DIYers do. So when you're jumping into a field that is much more complex, has a lot of moving parts, you better be willing to understand those moving parts. And if you're not, then you'll get bit by that animal. And that's exactly what most of these end users get. He's a content creator. You would have thought, once again, I'm not going to post a video until I know that the information I'm posting is accurate. He doesn't. He doesn't even know where the breakout board is made. Again, fact. So where, once again, do you draw the line? And that's why I tell you guys, save your money. You are much better off investing with validated sources than you are just going on forums, wasting your time, because that's all you're doing. I mean, they don't know any more obviously than you do. And then on top of that, they're directing you with your money. Would you make investments based on people you don't know? Would you go buy a house? Would you go buy a car? That's ridiculous. So I have no idea why these people continue to do this, let alone a content creator, and then post that. Again, be cautious. Do research based on validation, on people that are doing it, that have hands-on experience, that are doing it in a fashion that holds them responsible. There is no responsibility held here. And if he did purchase this from any vendor, let alone the one he mentioned, which I've already done numerous videos on, then hopefully that vendor did not tell him that that board is manufactured on American soil, because we know it's not. As a matter of fact, I'll put it on screen here where that board comes from. The price of the board should tell him everything he needs to know, and should tell all of you everything you need to know, because if this board was actually priced at that rate and was stable, there would be everybody using it. And I always say that point of logic. If it worked so good, everybody would be using it. Why would I not be selling that to you? I mean, everybody wins. I make more money. You guys get a stable system. Everybody wins.
And it has great support, lots of online videos to teach you how to install it and program it and run it. I had to add some components in. I just have them kind of stuck in right now with foam tape.
First and foremost, we should not be mounting any components with double-sided tape. The circuit boards that have components he's mounted actually has 4 holes to be mounted with standoffs in your electronics enclosure, and that's best practice, not just for correct mounting, but also, most importantly, safety. Now, I don't know why anyone would do this except to get the job done as quick as possible, to get the video uploaded for AdSense, which, again, I'm just calling out the facts here. No one would go about doing that. These should have been mounted properly. If he's just temporarily doing that, don't put it on camera. Because again, it's not best practice, and we don't know who's watching that may follow what they're seeing. The content creator is now giving his endorsement of the board, discussing how much support is online and how many people can discuss the settings online. And here's what he fails to realize. As a content creator, we all need to be held accountable, because as our audience sees that we're posting more videos, they formulate more trust with the content that we're producing. In doing so, when you start showing that certain components you're using or products you feel are great, their natural association is to say, hey, you know what? I trust him. If he says it's good, I'm going to go out and buy it. That is what happens with influencers, which is essentially what we are. Now I'm going to put on screen the truth about this board. After doing an open Google search on the term bit sensor USB breakout board unstable, you can see in the second post on the Google search comes up where, once again, on a CamBam website, which is CAM software, an end user is discussing disconnect issues with this board. So now the question comes, who's accountable here? Should he be accountable to anyone in his audience now that's purchased this board and is experiencing that same thing after he's telling everybody how great it is with all the support? The support's not helping you if the board is disconnecting. The support should have been from the vendor doing his research so he's knowledgeable on what he's selling, so he is not selling bricks, which is essentially what he's providing end users if he doesn't know what ramifications come from using incorrect boards for signal manipulation. Once again, you guys be the judge.
Okay, so we cut our test piece. This piece is supposed to be a 4-inch square with a 1-inch hole in the center. We'll measure it. All 3 axes should be off the same amount. Showing 4 inches and 40 thousandths, so we're 40 thousandths over. We better do this at same here, about actually 41 thousandths. Let me try this again. And this one's showing 41 also. So we are oversized by 41 thousandths.
Well, the content creator is now doing test cuts, and he's performing what he feels is axis calibration. The robot appears to be stable. Everything seems to be moving. He followed the wiring pattern. Everything is connected, and being he's moving, and now that he's able to perform a test cut to give himself a measurement to put into Mach 3 so he can actually perform the axis calibration and have it make adjustments, he thinks the robot is done, it's stable, it's ready to go, like many content creators before him and like many end users before him. Let's see what happens.
I started cutting this mold and I got to the point to where I am now. I've had a few issues with the machine, and what happens is the Z-axis quits working, and basically the head here just drops and the end mill plunges into the part. It did it here and I wasn't quite sure what happened, so I restarted the machine and it did it here. So I knew I had an issue. I came out and started doing some checks. I don't know for sure what's going on, but it's a lack of communication between the motor driver and the stepper motor here. The motor driver or the encoder on the motor or the wiring in between.
I'm asking all of you now to think about what you've just reviewed up until this point. Many of you who are familiar with my channel realize that I've discussed unstable production robots and how to eliminate EMI and any type of build practices that would potentially give you an unstable production robot, defining what you just saw. This content creator put this in the video. Defining all that work that he did up until this point is useless. Now he's got to play the troubleshooting game. Now he's got to figure out, where is the gremlins? The question I ask all of you, and this is something that the trolls can't answer, is how much money did I just save you? You just watched this guy destroy a mold. We have no idea how much time it took him to do that, meaning we have no idea how much investment he's put into those molds. So let's think about this for a minute. What if it wasn't wood? What if it was carbon fiber or some other substrate of higher value? We already know the wood has value, but what if it's of higher value? What if the client needs that component for his business? Now it's destroying components. So you don't want to keep testing because the potential of destroying more components goes up, right? The level of consistency with robotics is exact. What does that mean? That means that if everything is working as it should, usually it will continue working as it should until a component fails or until a loop inside that component link of the chain of stability breaks. However, it works in reverse. And what I mean to say is, if that level of consistency has degraded to where the robot is unstable, now you have to factor in that variable. Every time you turn on the machine, that level of instability is there. Let's say, for instance, that level of instability is there, but the next time he runs the machine, it disappears, and it looks like, oh, everything is great. Is it? Is it? That is what bites most guys' asses. That is why most people that start businesses with this kind of equipment fail, because they can't figure out that, yes, everything in this business follows a pattern. Robotics are extremely consistent. People aren't. And that's why you have to think of this machine as a perfect machine. The only variable is you and your knowledge to detect when there's a problem. How do I troubleshoot it? How well are you able to listen to what that machine is telling you? One more quick point and a very, very important detail. We just saw a closed loop motor, because it does have an encoder. What does that mean to all the novice guys? That encoder tracks that motor's shaft position. So in theory, it's supposed to know where it is. So in theory, these mistakes should never happen, at least according to the forum dwellers. But it just did. You just witnessed it. He just explained it, not me. Although I've said this in previous videos. There is no perfect motor, guys. That's a fact. You just saw it. The question is, was there a warning LED to let him know he missed steps? Because even if there was, it wouldn't mean that it wouldn't. It's just letting you know it did it. Think about it. Is one better because it lets you know, hey, you missed steps? Or is it better to just say with the stepper, hey, I missed steps, something's not right? Because you'll find out either way. The question is how. He just found out it just bit him. So to all those people that think that these type of motors are so much better and they're going to provide so much more support in the sense of peace of mind because they'll track that motor's position as far as its shaft, what did you just see? That's what he claimed he paid for. I'm sure that's when he actually looked at purchasing these. People online were telling him these are so much better. So what did you just see? Right. Many of you are answering it and you know it in your mind. It's all up to the end user. If the end user builds in instability, it doesn't matter what motors you use. The incompetence carries over. And that is my point. You could buy the best car parts in the world to build the best, fastest supercar. But guess what? If you don't know how to assemble them, it means shit.
I wanted to take a couple of minutes and explain what all I did to get the CNC working again. First thing I did was order a driver for the Z-axis stepper motor. I thought the driver may be going bad or intermittent, and I wanted to replace that first, so I ordered that stepper motor driver, installed it. It did not solve the problem. It was still doing the same thing. So I thought maybe it was a stepper motor because the stepper motor was making a real high-pitched squealing noise, like maybe the motor was going bad or it was constantly trying to find the correct position, which would show that maybe the encoder was going bad on the stepper motor. So I ordered a new stepper motor which came with a driver, so I had a matched pair, and installed the stepper motor and driver, and that did not solve the problem. It was still doing the same thing. Next, I thought it might be the wire between the encoder and the motor driver, so I took the all-meter and did a continuity check on all 6 wires from end to end, and the continuity check showed all 6 wires to be good. And at the same time I was doing the check, I was taking and shaking the wires, trying to see if I could get one that may be intermittent to act up and give a bad signal or no signal and not show connectivity. And I never did. So I assumed that wire was okay. I moved on trying to find other things. I was running out of ideas. I posted a question on a Facebook CNC user group for people to come up with ideas maybe to give me to try. I did get a couple of good ideas. One was the power supplies. I am running a separate power supply for each axis, and someone suggested maybe one of the power supplies was going bad. So what I did to test that was I switched the power supplies on the X and the Z axis, which...
I have to ask all of you a question, and that is, how exciting does it sound spending all of that money and time troubleshooting to decide what this problem is? I mean, truth be told, I did tell you at the beginning of the video, this one's different because it actually defines what I've seen as a vendor, because I actually support my equipment. This is what I see. I get the aftermath, this. You contact me after the fact. Unfortunately, had he followed different suit of going down the same rabbit hole, I'm just going to keep spending and spending and spending, wasting more time and more time and more time. We could have isolated the problem, breaking it down in a fishbone, and then once we did that, we could have isolated the problem by, okay, now it's time to rebuild the controller so that we can get everything right. No one wants to hear that, but that's what needs to be done. And on top of that, this novice end user / content creator goes on the forum once again to get opinions, which ended up putting him back in the same boat. Because let me tell you what, checking a power supply, that would not cause that problem. He would have detected that immediately with a multimeter. Power supplies just put out voltage, guys. That's it. I've never, ever, in over 10 years of being online doing this, had a power supply cause the issue he's talking about. But I have had EMI do it. This is the point I'm trying to make. You now get to see exactly what I deal with and exactly what you'll deal with if you follow these content creators. He was honest enough, and I have to say, it's not commonly done, to put all of the ramifications into this. We still don't know how much time and money he spent trying to correct this. That's the missing component. But knowing that he had to go through all of that and he put this in the video, it's a real benefit to many of you if you're willing to learn from others' mistakes, as we all should. And that's the purpose of these videos. Let's see where this goes.
If it was a power supply problem, would have moved the problem from the Z-axis to the X-axis, but that did not happen, which told me that it was not a power supply problem. So the only thing left that it could have been was the cable running from the encoder to the motor driver, which I had done the continuity check on and it passed. So a friend of mine gave me some shielded cable to replace that cable with, and I completely cut out the old cable. That cable had two connectors on it, one like a bulkhead connector at the back of the electrical box, and then a 9-pin, I think it's like a D-type or something, like a computer cable that was on a pigtail at the end of near the stepper motor. So it had a stepper motor had a 6 or 9 inch pigtail and then this connector on it, and it was factory installed. So I cut all of those out, ran a wire straight from the stepper motor to the motor driver, and ran some tests. I did an initial test running part of the program, the cut program, with the end mill out of the spindle motor and the spindle motor not turned on. And I ran that program for probably 10 or 15 minutes, and the problem appeared to go away. The machine acted fine.
I actually hear this done a lot, where guys will say, I do my testing to see if I leave my spindle off, how the robot is going to behave as far as being stable. Let me ask all of you this question. If I'm going to run a simulation for stability, as an engineer, I would want all variables to be the same, as you would want, right? That means that you don't cut with the spindle off, you cut with the spindle on. So if it's cut with the spindle on, and that is a major variable of the robot being the production robot it is, because without the spindle, it's a paperweight other than just moving around, then it inherently is required for the spindle to be on in a direct simulated format. The more amount of variables you can eliminate that would hinder the performance to be as it would if it's physically doing the work, then where are you going with this? Because you're not getting reliable results, meaning the simulation is telling you nothing. That's why in CAM software, when you run the simulation, the CAM software just goes through and runs like a program, because that's all it is a program. You can't do that so easily with the hardware because, once again, he decided to leave the spindle off. He thinks, oh, well, everything's good. The spindle's off. It's stable. Is it? If the spindle's off, we don't know how it's going to act when you mount the end mill and the spindle's on and it's cutting. Let's see what happens.
So I rewired, completely removed the old cable, rewired with the new cable, and soldered it to the bulkhead fittings on the electrical box, and started the machine, and everything is working correctly. So there was a problem somewhere in that 6 wire shielded cable. I don't know if it was a bad place in the cable somewhere or one of the 2 connectors. I didn't take the time to fix it. I guess it's kind of irrelevant where the issue was.
So the content creator explained to us he feels he had a bad cable. That cable was replaced with a shielded cable, and he didn't specify whether it was double shielded, which is best practice, but he changed the cable. Miraculously, all the problems went away, according to him. Now I'm asking you, being this one problem was surrounding the Z-axis, did he correct the entire robot as far as stability? Because most end users I speak to who are novice feel that the problem is solved and stop. That is what bites most guys. They think that the robot telling them, hey, it's this axis now that's unstable. Okay, I'll just fix that and everything is good. You're not Bondoing a car where there's just one dent in one spot, guys. The fact of the matter is, if the controller is built from the ground up incorrectly, guess what it needs to have? Done from the ground up. Be rebuilt correctly so that we have an inherently stable robot because things are done in best practice. What does that mean? That means that if he has one axis that he's corrected because there was an unstable problem that actually made the axis do things it wasn't supposed to do, he still has 2 remaining axes to be corrected because they're still using stock cables. So Where do we draw the line? And that's why I'm telling you, this is a big, big elephant you guys are trying to eat. And a lot of guys don't understand that. And a lot of guys, truthfully, they don't have the time investment or the budget to look at this as being corrected from the ground up. That's why most guys get pissed at my videos, I feel, is because they look at what I charge and then they see this and then they go, I can't afford that. I just can't do it. Okay. Normal people would say, hey, you know what? I'm not going to piss away money on a $5 USB breakout board, which this guy keeps saying is unstable, unstable, unstable. I'll save until I have enough money to do it right. And you know what? That's what we all do. The people that are the most intelligent tell me the same thing. Vin, I had to save. It wasn't something that I wanted to do. I had to save. I took money out of my 401k. I wanted to start a business. This is what I did. And guess what? They do it. And they do it systematically, and they never run into problems like this. Because once you run into a problem like this and only fix like he did with a Band-Aid, you're going to find it will potentially bite you again at a later date. And when it does, it's usually the worst possible time. I tell all of my clients that. An unstable production robot is terrifying. Because not only is it costing you time, it costs you mass amounts of money, but you never know when. Because you'll put that substrate on there and you've got a client that's breathing down your neck. Hey, I've got this deadline I'm going to be focusing on. And all of a sudden you run into issues. And then I have guys say to me, the trolling ones that'll say, oh, well, in best practice, you shouldn't have a deadline. You shouldn't be listing here. You shouldn't be listing there. That's business, guys. That's business. If you're going to take work on as a custom manufacturer, which is essentially what most of these guys are doing, not in this case particularly, but overall, then what you do is you take that responsibility to meet that deadline. It's part of being accountable once again. So in the event something happens, where you at then? Then I have guys, oh, can you overnight parts on Saturday? Sure. You know what Saturday delivery costs? Think about it. What you just seen here in this video is probably one of the best presentations of not just me telling you what is the potential for an unstable robot, but actually seeing it defined by the content creator himself. Once again, I want to thank everybody for watching a video this long. Again, I'm not going to apologize for making videos this long because I feel there's a lot to learn. And if you're one of them 10-second guys where you want to watch a YouTube short, this is not your channel. If you really want to learn something and something that will save you money and can make you a lot of money, then I feel the time investment is worth it. Thank you all for your support. Take care.